Hello class. Today we are going to examine functions by at first looking at a verbal description and using that information to complete a table, a graph, and finally an equation. So let's begin by reading the verbal description. The 8th graders rode a bus at a constant speed of 50 miles per hour from Louisville, Kentucky to Chicago, Illinois. These two cities are 300 miles apart. The students traveled for 6 hours. So let's ask ourselves, what do we know that we can put into a table? We know that we're traveling an amount of hours. So we know that time is usually x, so let's go ahead and put number of hours in for x. And we know that we are traveling to a place. So for this function, we're going to have our y as the distance from Chicago in miles. So when we first begin our trip, we know that we are 300 miles from Chicago. We haven't been on the bus for very long. It hasn't even started. We have 300 miles to go. Then the bus starts to move. We move for an hour at a constant speed of 50 miles per hour. So, of course, 1 hour has passed. So we have gone 50 miles. It's a constant speed. But the thing about this is that we're going towards Chicago. So it will change our distance by 50. We subtract the 50 miles because our y is representing how far we need to go yet to Chicago. So in 2 hours we go another 50 miles. 250 minus 50. We have 200 miles yet to go. We continue subtracting these 50 miles each hour. In 3 hours, 150 miles. In 4 hours, 100 miles. In 5 hours, 50 miles. And in 6 hours, we are there. 0 miles left for the journey. So that is how we fill in a table. And from our table, we should go on to our graph. But as I look here, I see that there is something missing. We have not yet labeled our x and y axes. So we should do that because on every graph we need to label our x and y axes. So our x axis is time. We've said this again and again, that time is usually located on the x axis. And for this word problem, time is in hours. It's not in weeks or minutes. It's in hours. It's abbreviated HR. Our y-axis is our distance from Chicago. So, I'm sorry if this is sloppy, guys. I'm trying to write it with a mouse pad. Distance from Chicago. I'm just going to put a capital C for Chicago, and that is in miles. The abbreviation's usually in parentheses, or the unit. Okay, so now that we've labeled our axes, we can plot our points. Our first ordered pair is 0, 300. In 0 hours, we are 300 miles away from Chicago. In 1 hour, we are 250 miles away. The only problem we have right now with this graph is that we only have 260 and 240 labeled on the y-axis because of the scale. We went up in 20s. But we know that 250 is halfway between 240 and 260. So therefore, we just put the point right there like that. Because see, that's halfway between 240 and 260. Okay, on to 2 hours. 2 hours, we are 200 miles from Chicago. 3 hours, we're 150. We do the same technique here because 150 is halfway between 140 and 160. In 4 hours, 100 miles. In 5 hours, 50 miles. Again, that same technique. And 6 hours, we are there in Chicago, 0 miles. Now, I'm going to connect my points, and that will give us a line. As you can see, a constant speed, a constant rate of change gives us a slope. And the slope is negative because the function is decreasing. And so we finished our graph. We completed our table. The only thing left for us to do is to write an equation. So I'm going to leave that up to you, the individual. If you would please write the equation of this linear function in the discussion tab. Remember, we want it in the form of y equals mx plus b, slope-intercept form, y equals mx plus b. Thank you for listening.